Okay, today we're going to be talking about a lesson from Algebra 1, Chapter 4, Section 1. We're going to be talking about graphing equations in slope-intercept form. Slope-intercept form is the most widely used form of an equation for a linear equation. So our objectives today, you're going to be able to write and graph linear equations in slope-intercept form, and you're going to be able to model real-world data with equations in slope-intercept form. So, an equation in the form y equals mx plus b, where m is the slope and b is the y-intercept, is in slope-intercept form. You use the slope and the y-intercept to write it in slope-intercept form. That's where it gets its name. So the variables m and b are called the parameters of the equation. Changing either value changes the equation's graph. So m and b are the only two things you need to put into this equation. So down here, we showed a little bit more clearly. Y equals mx plus b. Okay, m and b are what you need to plug in. Okay, so m is the slope as always, and b is the y-intercept. And we remember the y-intercept is where my graph crosses the y-axis. Okay, so for example, here would be an equation y equals 2x plus 6, where 2 is the slope and 6 is the y-intercept. Now we only plug it in for m and b because, again, the way an equation works is that each point along this line is an ordered pair, x comma y. We'll just say this is 2 comma 2, okay? X comma y that we could plug into this equation and it would make it true, okay? So that's why we leave x and y there. In addition, the real power of an equation is not that I can find easy answers, it's that I can find difficult answers. You know, it's easy to see that this would cross at 2 comma 2 or wherever it does, but it's difficult to see that where y would be if x was 2.73. Okay, so that's where the real power of an equation is. So you need to leave y and x in there. If we take a look at example number 1 here, it says write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2, then graph the equation. So if my slope is 3/4 and my y-intercept is -2, all I need to do is plug those in to y equals mx plus b. Plug m in for m, plug b in for b. Y equals 3/4 x plus a -2. Now, in algebra, we don't like things looking messy like this, plus a -2. So we want to rewrite that as 3/4 x minus 2. So y equals 3/4 x minus 2. So to graph it, it's very simple compared to the other methods we've used before, which include using both intercepts and then making a table. So here we always start with the y-intercept. Start with b, the y-intercept. So my y-intercept's at -2. So over here on the y-axis, I go down to -2 and I put a point. Okay, now I only need 2 points in order to draw a line, but really it's helpful if I have a few. So I'm going to use the slope to find more points. Use the slope. So my slope is rise over run. And my slope for this equation is 3/4. So that means it rises 3 units for every 4 that it runs. So from my point on my y-intercept, I know my line will cross here. So my line has to go through here at some point. Now I just use my slope to count out another point. So if it rises 3, 1, 2, 3, and runs 4, 1, 2, 3, 4, I know another point's going to be right there. And I could find another one. Rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. Okay. So that's where my line is going to be. If I take out my ruler here, I can connect those points into a nice line just like this. Arrows on each end, and there you have it. So a couple things to note. Remember, your y-intercept is always on your y-axis. That's where you start. And then when you're using your slope make sure you understand that if you are working with the rise, positive means up and negative means down. If you're working with the run, positive means right and negative means left. So why don't you go ahead and pause the video and try 1A and 1B on your own, and I'll be back in a minute to show you how these go. Alright, you should be back from trying 1A and 1B. I'll quickly run through these so you can check your answers. If I have a slope of negative 1/2 and a y-intercept of 3, y equals mx plus b ends up being y equals negative 1/2 x plus 3. So in order to graph that, I start at my y-intercept, which is a positive 3, so I count to 3 on the y-axis, 1, 2, 3. And to find another point, I use my slope. Rise over run, negative 1 over 2. So I go down 1 to the right 2. Down 1 to the right 2. Okay. Now I have 3 points. Now I can very easily draw a line. And there it is. Moving on to 1B. If I have a slope of negative 3 and a y-intercept of negative 8, my equation should be y equals negative 3x minus 8. Okay, so again, I start at my y-intercept of a negative 8, count down, 1, 2, 3, 4, 5, 6, 7, 8, put a point. And now I'm going to use my slope to find another point. Now my slope, again, is rise over run. And if I have it as negative 3 as a fraction, that's negative 3 over 1. Well, here's the problem. If my rise is a negative 3, I run out of room. Okay, so what we have to realize is that negative 3 over positive 1 is equivalent to 3, a positive 3, over a negative 1. So that's what we can use here. So if I have a rise of a positive 3, 1, 2, 3, and a run of a negative 1, since the run is negative, I move to the left. There's my point. And I could count out several of these. 1, 2, 3, back 1, 1, 2, 3, back 1. Now I have several points, draw my line. So it's important to understand what you have on your graph and what you need to use, and also mathematically how a negative sign affects a fraction. Negative 3 over 1 is equal to 3 over negative 1, which is equal to the whole thing being negative. They're all equivalent. But in terms of rise or run, you have to have the negative sign either on the top or the bottom. Both will work as long as you have the correct sign. Moving on, example number 2, it says when an equation is not written in slope-intercept form, it may be easier to rewrite it before graphing. So here we have an equation that's written in standard form. Previous to this, we would have used the cover-up method, but now we really want to work on slope-intercept form. So right now I want my goal to be y equals mx plus b. So essentially, if you look at this, what you want to do is get y by itself. So really, you're solving this equation for y. In order to do that, I subtract 3x. Okay. Now remember, my goal is to get in y equals mx plus b. So I'm going to put this negative 3x in front of the 6. Okay, and now I need to divide by 2. And when I do this, I need to divide everything by 2 over here. Okay, so I take the negative 3x divided by 2, and I take the 6 divided by 2. Okay, that cancels. When I do that, I'm left with y equals negative 3 over 2x plus 3. Okay, so that is my equation. Now, in order to graph it, I do the exact same thing I've done all lesson. I go up to positive 3, 1, 2, 3, put a point. Now I use my slope to find more points. Negative 3 over 2, my rise is down 3 over 2, and I can find as many of those as that will fit on the graph. 1, 2, 3 down, 2 over, there's another one. We'll call that good. Here's my ruler. And there is my line. So if you're given an equation that's not in slope-intercept form, put it in slope-intercept form, because slope-intercept form really is probably the easiest to use. So go ahead and take a minute to try 2a and 2b, or not 2b, that is the question. And I'll be back in a minute to go through those. All right, we should be back by now. In the interest of time here, I'm going to go through these rather quickly, so feel free to rewatch the video if I'm going a little too fast. So again, we want to solve for y to get it into y equals mx plus b form. Subtract 3x. I end up at negative 4y is equal to negative 3x plus 12. Divide everything by a negative 4. So y equals a positive 3/4 x minus 3. To graph, I go down negative 3, 1, 2, 3. Up 3/4 for my slope. 1, 2, 3, 1, 2, 3, 4. There it is. 1, 2, 3, 1, 2, 3, 4. And draw my line. To b works in nearly the exact same way. I add 2x to both sides because I want to solve for y. So I end up at 5y is equal to 2x plus 10. Divide everything by 5, and I get y to equal 2/5 x plus 2. So on the y-axis here, I go up to 2, 1, 2. There's my y-intercept, 2/5 up 2 over 5, so 1, 2, 1, 2, 3, 4, 5, and put a point. 1, 2, 1, 2, 3, 4, 5, put a point. Draw my line with my ruler, and there you have it. So moving on, we have a couple of special cases. Except for the graph of y equals 0, which lies on the x-axis, that is the x-axis, y equals 0, would be a line right there. Okay, horizontal lines have a slope of 0. They are graphs of what we call a constant function. They don't vary at all. It's the same value the entire time. So, which can be written in slope-intercept form as y equals 0x plus b, or y equals b, where b is any number. So the constant functions do not cross the x-axis. Their domain is all real numbers, and their range is b. It's always b. No matter what you plug in for x, you always get b out. So here we have the equation y equals negative 3. Negative 3 in this case would be b. b, as always, stands for my y-intercept. So I know this is a horizontal line that crosses at negative 3. So on my graph, I go down to 1, 2, 3. So if it's a horizontal line, I know it's going to be straight through that point. So I can just draw my best attempt at a horizontal line here. And there you have it. It is that easy. Y equals negative 3 is a horizontal line. And again, we call it a constant function because the value doesn't change. No matter what I plug in for x, 1, 2, 3, 4, 5, the value is always negative 3. So it is constantly negative 3. That's why it is a constant function. Go ahead, take a minute if you need a whole minute to try 3a and 3b, and I'll be back to show you these ones. So you should be back from trying 3a and 3b. Y equals 5. That's a horizontal line at 5. 1, 2, 3, 4, 5. Put a point. Draw your line. No need to make it any more complicated than that. You just have to be able to recognize and understand that if y equals 5, that means my slope is 0, and a horizontal line has a slope of 0. So we take a look at 3b. Now I have 2y equals 1. In order to graph this, I need to solve for y. So I divide by 2, and I get y to equal 1/2. So now I have a horizontal line at 1/2. So instead of going all the way up to 1, you go to 1/2, put a point, and again, draw your horizontal line. This one will be a little bit tougher, but we'll get as close as we can to horizontal. And there you go. So, moving on to example number 4. There are times when you will need to write an equation when given a graph. To do this, locate the y-intercept and use the rise and run to find another point on the graph, then write the equation in slope-intercept form. So it's called slope-intercept form. The two pieces of information I need in order to write an equation in this form are the slope and the y-intercept. So those are the two things you need to find to make your equation. So here's the graph that we are given. The first thing I'll note is the y-intercept. The y-intercept is right there at 1. So I know b is equal to 1. And from there, I just need to find another lattice point here so I can count the rise over the run. And a lattice point is right where the lines intersect. And the reason we pick those points is because I know the value there. So for example, right here, I know the value is 1, 2, 3, 0. Okay, exactly. If I were to pick this point here, I'd know it's exactly 2 on the x, but on the y, I don't know what that is. 0.25, 0.27, 0.3, I don't know. So I choose a lattice point right here so I can easily count my rise over my run. So my slope would be -1 over 3, or -1/3. So now if I'm going to put that into an equation of y equals mx plus b, that would be y equals -1/3 x plus 1. If we look at our choices over here, that is C. So really it's just about identifying the y-intercept and finding the slope. Two things we should be very familiar with. If we try another one here, under the guided practice, why don't you guys try this one on your own. Pause the video and we'll be back in a minute to show you how this one goes. So you should be back from trying example guided practice number 4. Again, we start with our y-intercept. This time it is -1, b equals -1. And then I count my rise over and run to another lattice point, and it looks like we have one right there. So my slope would be a +1 over 1, 2, 3, 4, or 1/4. Therefore, my equation is y equals 1/4 x minus 1. If I go look at my choices, it should be F, the first one. So moving on into the second part of the lesson here. Modeling real-world data. So real-world data can be modeled by a linear equation if there is a constant rate of change. The rate of change represents the slope. The y-intercept is the point or the value where the independent variable is 0. We a lot of times call that the initial value or the starting point. That is what the y-intercept represents. So it says use a linear equation to find the number of girls in high school sports in 1997. So on my PowerPoint here, it looks like I'm missing a little bit of information. Basically what it says, in 1997 about 2.6 million girls competed in high school sports. The number of girls competing in high school sports has increased by an average of 0.06 million per year since 1997. Okay, so our rate of change, if it's increasing by 0.06 million, our rate of change is 0.06. Okay, and then our initial value, because we're working after 1997, so our initial value is the value that it was in 1997. So that would be 2.6. And again, these are in millions, but we're going to leave them like that. So our equation would be y equals 0.06x plus 2.6. So in order to graph this equation, what we want to do is on the bottom we're going to go years since 1997. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then on the side here we can have millions. Okay, and let's go by Let's go by 500,000 maybe. So we'll go 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. So we start at our initial value of 2.6, which is about here, okay? And then it's going to get bigger by 0.06 million each year. So if I go up 0.06, it's going to be almost hard to tell how much it's going up, okay? But it won't go up very much, very fast. So it'll be a pretty flat line that kind of looks like this. Now, one of the problems with graphing by hand is that you just can't really be as accurate as you need to be. We could graph this on our graphing calculators and be extremely accurate, and that's what most people who are working with real life situations do. However, it is important that we understand that we can graph it by hand. So now it says estimate the number of girls competing in 2017. So in 10 years since 1997, this 10 down here would represent 2007. Okay, so we don't have this on the graph. So what we need to do is figure out what we could plug into our equation. So X represents the years and Y represents the number of girls competing. So in 2017, that would be 20 years since 1997. So what we want to do is plug in 20 for X, and that will give us our answer. So 0.06 times 20 plus 2.6. So now we take 0.06 times 20, which is 1.2. Y equals 1.2 plus 2.6, and that should be 3.8 million girls. And that really is the power of a linear equation in a real life situation, is being able to make predictions. On a basic level, this is how a lot of predictions and estimates are made in the financial markets, in populations and things like that. You take your growth rate and what you're at now, and you can make a basic prediction of where you're going to end up if that growth continues. So obviously in those situations it's much more complicated, but it's kind of a basic concept that gets applied. So in the interest of time, we are going to skip the guided practice number 5 and move right to the assignment here. Here on page 220, 17 through 37 odd, 59 and 63. Alrighty, please let me know if you have any questions. Thanks.